So we are also looking for paper together. First, I will briefly introduce Markowitz Portfolio theory, which is calculating variance and calculating expected return to formulate perfect portfolio. I will give an example with two assets. If I say there is asset A, which shows this is the each day of the price from day 1 to day 5, and there is asset B, which is from day 1 to day 5, there is price. The asset A's price is going start from 100 to 110, and asset B's price is start from 50 to 58. Then we can easily calculate each day's difference. Then we can calculate each day's percentage, the fluctuation of each day. Then the return for asset A are 2%, 2.9%, and we can calculate this and we can make one vector. For asset B, we can do the same thing and we can also make another vectors. Then by that, we can calculate asset A and asset A and asset B's expected return. Then from expected return, we can easily calculate the variance and correlation of each stocks. We also find covariance of stock A and B. And now what Markowitz portfolio theory do is we will choose the return that we want. And by the return, we will minimize the variance. This is what Markowitz portfolio do. So then the variance, the sum of the variance will be 1. And if you calculate the variance, it is 0.01 point something. And we will calculate covariance matrix, which is, this is the element. And we can get the matrix. And from it, we have variance matrix here. And we will also get expected return vector here. Then we do two things together. We can get variance of two assets, which is portfolio. We can get variance of portfolio. Then we will get every value to this metric, matrix, and we will calculate it. And the one thing important thing is the other value is calculated, but the expected return here this is U. Expected value is, we will assume the expected return that we want. So maybe we can assume here as 0.1, but in this calculation, I suppose it as 0.03. Then after the calculation, after the kind of complex calculation, we can get portfolio standard deviation, then which is, it will be 1 point up here. We assumed 0.03 of expected return, and we get 7.38% of standard deviation. Then we can get 1 point here. Then also we can assume another expected return. Then if we calculate every standard deviation on our assumed expected return, then we can get a lot of many points. Then based on that, we can draw the tangent line, which we can make tangency portfolio. This was very brief Markowitz portfolio explanation. If there's any question, if there's no question, I will go to Kelly portfolio and go straight to transaction cost, which is what we are going to discuss today.
Could you go to slide 13?
13.
How, I don't understand understand the matrix multiplication, how the second one we have. Oh, never mind. It's fine. But could you explain the first matrix multiplication? What's going on there? I didn't.
This
Or
part,
yeah.
this is, wait a minute. This is actually each part that we already calculated before. If we go below, this is its variance of the stock, and here W is its variance of the stock, and this is expected return we wanted, and this R is the return vector that we already calculated before with the 5 days of stock price. We calculate the return vector of asset A and asset B, and this sigma is disparate covariance matrix.
Okay.
Return vector is disparate. And the return vector is calculated by this step, which is 5 days of their price. We get the percentage of fluctuation of asset A and B. By that, we get return vector, and everything comes together here to calculate matrix. Okay, this was a very brief Markowitz portfolio. If we go deeper, then there will be a lot of matrix calculation. So today I will pass it. Maybe next time there will be another opportunity to look deeper. In this picture, also there's a lot of interpretation and things that we can look up. But today I will pass it because today is just the introduction of Markowitz portfolio. And there was Markowitz portfolio, and there is also Kelly criteria, which is investor use a lot. It is actually a little bit difficult notion, so I will just briefly explain. Kelly criteria is, if we see the parameter, this is the probability of win, and this is probability of lose, and this is how much I can get from the betting. So I can calculate how much I should bet in one bet. This is the very brief notion of Kelly criteria. So if I can win with 60%, then it will be 0.6. And if I want to bet $1 and I will get $10, then B will be 9, because if I bet $1 and if I can get $10 or $0, then the ratio is 1 to 10, so B will be 9. Oh, wait a minute. Proportion. So 1 to 9. B will be 9 or 10, but I'm a little bit mixed up. The important thing is B is how much you can get by proportion to how much you bet. This is another version, but it is similar. L, there is just one more parameter comes out. L is the parameter that how much you will lose if you, after you pay. And you can apply this Kelly criteria to stock market, which is in continuous form, but it's actually same fraction of available capital invested that maximize the expected geometric growth rate. Actually, we need to discuss more about how Kelly criteria can represent expected growth rate from how much they should bet. So this was Kelly criteria. Kelly criteria, I think my explanation is, I think there's not thorough explanation. But if there's any question, maybe we can figure out together. Do you have any question? Or maybe I can answer to you next time. It was a little bit difficult to me. Okay, then I will go to transaction cost. Transaction cost is the main part what researchers are researching right now. Because if there is no transaction cost, you can easily calculate the stock when you should buy and when you should sell. If we assume we know the stock market's future price from T0 to T5, T0, T1, T2, T3, T5. If we know the stock price, then it is very easy to sell and buy when we should sell and when we should buy. But if there comes transaction cost, then it is very difficult to calculate when we should buy and when we should sell, because even stock prices go up, but maybe it is loss for us because transaction cost is maybe bigger than the gain that we can get. So this is two paper about transaction cost. In the first paper, they calculate the transaction cost by first they set up the uh, weight of vectors. This is each person they invest their own asset, which means this is stock A, stock B, stock C, which means they give their person uh, their asset investment to A to 0.2 and to asset B 0.4 and to asset C 0.4. After they invest their asset, there was price fluctuation, which is asset A's price is increased by 2.5 times, and asset B's price increased with 1.1 times, and asset C increased with 1.1 times. Then after the fluctuation, their weight will be different. Their weight will be changed by if we multiply each of the element, and if we sum up, then it will be 1.38. And two, wait a minute, and over two. Oh, I'm not sure. I think I did something miscalculation, but their weight will be changed like 0.5, 0.44, and 0.44. Their weight will be changed. And this is the part that I didn't really understand it. What they are doing is after the weight changed from their original weight to their weight is changed to 0.5, 0.44, 0.44. Then they calculate the transaction cost as like this from WTI to UT is how much they sell. So WTI minus UT, WT, comma I, and with the commission rate. This is how they calculate the total amount of cash obtained by all selling. The problem is I feel confused because I'm not sure why they need to calculate the transaction cost like this. So maybe I want to also ask your opinion why they formulate the problem like this, especially this modeling.
Which equation is it that you're not sure why they're using it that way?
Yeah. Like for rate of return, I can easily figure it out because it is calculating it from ut yt dot wt minus I. If we
Mm,
see here, then
hmm
it will be their element product wise, which is after they give their portion of their money to each asset A, B, C, and their asset rise with this portion, then they should multiply each of this asset to they can figure it out how much their asset is go up, and if they minus one,
mm.
they can get how much they earned. So we can easily get rate of return. But uh, while calculating transaction cost, mm, first they are using commission rate factor. So they already minus some commission rate, but also
hmm
calculate the difference between they calculate the difference between W prime TI, which is here, period T, ending of the period T, to top WT, comma I,
hmm
which is start of the period T plus one, with the UT. UT is the kind of vector which is represent the vector, which is the side effect transactions shrink the portfolio from 2PT is the vector.
Yeah, yeah.
I think they calculate two times because there's commission rate factor, and there's also shrinking factor. And I'm not sure
Mm.
how they can represent this with shrinking factor. Shrinking factor is kind of multiplying things. If it is not a like multiplying things, we can't like
Mhm.
represent with multiply you. This is kind of problem.
Well, so mu of t is going to be like there's going to be some portion of loss, and presumably that portion of loss is going to be equivalent for all transactions at that time. Um, like it's just going to be an inherent loss as you do those transactions. An example would be where a broker might charge a flat rate. Like a broker might charge a flat rate, or they might charge a percentage rate, which would be if it's a percentage rate, it would be mu of t. But mu of t would not work for a flat rate fee.
Mm.
Yeah, I don't know exactly the financial aspects of it, but looking at SJP, which is um, I'm not exactly sure, but it's some finance group. They have a list of ISA and unit trust funds,
Mm.
and they're giving the estimated transaction costs for different trusts. As an example, the Asia Pacific has a estimated transaction cost of 0.19%,
Mm.
and corporate bond has an estimated transaction cost of 0.2%. So for a corporate bond, for example, mu of t would would it be 99.8? Or yeah, it would be 99.8, I believe, would be your mu of t. So I think mu of t isn't something you're supposed to derive. It's something that's just provided. Like it's something you have to do these transactions to begin with.
Then do you think what is the role of difference between commission rate and mu of t?
Commission rate. So the commission rate is, I think that would be like the brokerage fee. Yeah, the commission rate would be what the brokerage takes. And a transaction fee